Hello there and welcome. In this video, we will be talking about the normal distribution. We're gonna be talking about the area under the normal distribution and how to find the probability of seeing an observation with that value, with the value that we observed in. We will be looking at the heights of people as our distribution, and we will be doing this in Python and Excel, so you can follow along in whichever you feel more comfortable with. We're just explaining the concepts, and we will be working with a sample because there's about 8 billion people in the planet and we don't know the heights for everyone. So we do get a sample and we start working from here. We will jump now to Excel. And in Excel, we will be looking at this thing that I started constructing before talking to you guys. We have the first column, the ID of the person. So we have person 1, person 2, person 3, etc. Then we have the height of those people. It is very important to know that a normal distribution can be defined by the mean and the standard deviation of it, just by those two values. And I wanted to talk to you guys about what was the standard deviation first, because we're trying to go very granular on this. So this is the formula for the sample variance, and the standard deviation is going to be the square root of that. And in here we have, for example, if this is the value of an observation and this is the mean of it, because this is the average formula for Excel, then in here we just get the observation, we subtract the mean, then we square it. Over here we get the sum of that number and we divide it by 99 because that's 100 minus 1, and that's the denominator of this formula. After doing so, we get the square root, and that's our standard deviation. That's how we find it. The variance is just a measure of the variability within the data, and the standard deviation is the square root of that. And we'll be using it to describe our normal distribution. I also had a Python notebook that I wanted to share with you guys, and it's this one. In here we kind of simulated a normal distribution as well with this code, and I just wanted to show that the larger the sample, the more likely it was going to be similar to a normal distribution, the plot that we see over here. So if I say that I want it to be 100 and I run this, now it doesn't look so smooth. But if I don't want 100 but rather 10,000, I run it again and it's a lot smoother than it was before. Right now, we will start by we will continue right now by defining what this z-score is. So a normal distribution has multiple properties that makes it easy for us to work with it. The first one is that the elements of a normal distribution, like 68% of the observations would be within one standard deviation from the mean, and 95% of the observations would be within 2 standard deviations away from the mean, which is very nice to know. And for us to find the area under the normal distribution through a cumulative cumulative distribution function, we would calculate something that's called the z-score. Now, the z-score really is just the value of the observation that we're interested in calculating the z-score for, minus the mean over the standard deviation of that distribution. For example, we'll go back to Excel and then we'll come back to Python. I'm just gonna go ahead and I'm gonna plot our 100 observations in a histogram. And instead of calculating the z-score manually, I'm gonna go ahead and do something that's a lot faster. And I'm gonna use normdist in Excel. I'm gonna grab whichever value I'm interested in. We know that the mean for this sample is 5.7, so I'm just gonna plug it in. And we know the standard deviation was 0.60. We want it to be cumulative. So the value that we selected here is 6.40, and it would lie around here. And what we obtain from this little formula that we did here is that around 80% of the observations in this sample are lower than that number. That is, around 87% are lower than 6.4. And that's true, because if we look at this, if we sum everything that is in here, that number would be around 87% of the observations. So the probability of finding someone, so if I look up people and start measuring their heights, the probability that I will find someone that is shorter than 6.4, given the attributes of this distribution, which is the mean is 5.7 and the standard deviation is 0.6, and that is the normal distribution, the probability of me finding someone who is lower than 6.4 are around 87%. Likewise, the probability of me finding someone who is taller than 6. Now, to answer the question of how did we get here, because we started talking about the Z-score and then I jumped into there is an easier way to do it in Excel without needing to calculate the Z-score. It's always good to know the concept. We've been talking about the normal distribution of our sample of people and the variable of their heights. It has a mean of 5.7 and a standard deviation of 0.6. However, there is another normal distribution that's very commonly used that's called the standard normal distribution. This standard normal has a mean of 0 and a standard deviation of 1. And we use it as a reference to find the relative distance between any of the points or observations of any normal distribution with its mean, given the mean that it has and the standard deviation that it has. Earlier, we were saying that we could use a formula that is the observation minus the mean over the standard deviation to get the Z-score. The Z-score is this measure of relative distance to the mean. And we find that relative distance to the mean in the standard normal distribution that we just mentioned that has a mean of 0 and a standard deviation of 1. For that, we need to calculate the Z-score. We could go ahead and do it right now. It would be any of the observations. We can stick with 6.4 because it's the one that we had been working with before. We subtract the mean and we divide it by the standard deviation. That's going to give us a number. And we look up that number inside of something that's called a Z-table. And we find the probability of seeing someone with that value in a normal distribution. So it's the same, it would give us the same answer as this one. This is just a longer manual process. And if you're in Excel, please use NormDist because it's going to be a lot easier for you and a lot faster. That being said, there is still a couple of things that it's going to be nice to understand about what we just performed. Closing the Z-score chapter, we're going to be working with NormDist in Excel because, again, it's just a lot easier. And NormDist actually stands for normal distribution instead of the Excel formulas. So, we said that the probability of seeing someone who is shorter than 6.4 is 87%. And that's true. And the probability of seeing someone who's taller than 6.4 would actually be 1 minus 87%, because probabilities need to add up to 1. And playing with these numbers, you could get the probability of any of the things that you want to know in this distribution. If you want to know the probability of someone being 6.4 feet tall, for example, you would actually need to calculate it with a range. And that's what we're gonna do next, just to familiarize ourselves a little bit more. So we're gonna put here norm this, and we're gonna do the same process. Instead of grabbing the value over here, we are gonna put 6.5 because we're looking for a range. We want the probability of someone being shorter than 6.5% and taller than 6.4. Because if I look for the probability of someone being exactly 6.4, let's remember that numbers can have infinite amount of decimals and the probability is gonna be 0. So I need to give a range, and that's gonna give us something that's a bit more actionable and understandable. So we just put here the mean. We said it was gonna be 5.7 and the standard deviation is 0.6. Then we say true because we want the cumulative distribution. And that gives us a number. It's 90%. Then, so we look up the probability of someone being shorter than 6.5 minus the probability of someone being shorter than 6.4. That's going to give us 3%. So norm dist is your function. Okay. The same way that we just use something that's called norm dist in Excel, we can use something that's called norm imp. And norm imp really is the same thing. However, this time we are asking for it to give us the value if we give it a probability. So given our normal distribution, if I want to ask Excel, so what would be a particular height that I would only find 5% of people who have it? And for that answer, we can just say norm imp, we give a probability. And when I say 5% of people would have it, I mean the probability of finding someone who's shorter than that height is 95% of people. So I'm gonna write here 95% because I'm interested in this little last detail here. I want to look up for someone who's very, very, very tall. So we put, to do so, we need to find the threshold for which 95% of people are shorter than. So we're gonna put 0.95. Then we need to describe this normal distribution to Excel. So we're gonna put here 5.7 and we're gonna do standard deviation, close parentheses, and here we go. 6.6 feet tall would be that number.